Hello and welcome to the lecture for January 30th, 2014, day 5 of class. Today we're going to be talking about logical operators, the switch statement, and ternary operators. So we have a bit to cover, but it's not going to be too bad. It's not going to be too bad. A lot of this is going to be expansion on the if statement in a couple of different directions. So by the start of class, on Thursday, January 30th. Ideally, you will have read sections 4.6, 4.8, and 3.6, which cover the switch statement, logical operators, and the ternary operator, respectively. All this is in your textbook. So, more or less in order. We'll talk about logical operators. We'll talk about Boolean short-circuit evaluation, which is one of the consequences of logical operators. We'll talk about the character, or the char data type, and a little bit more about the scanner. We'll talk about the switch statement, and then we'll talk about the ternary operator. Okay. So let's say, this is with regard to our logical operators, let's say that we want something to happen only if two or more conditions are met. Or, let's say that we want something to happen anytime at least one of several conditions are met. We can do this with Java. It's kind of a pain. Using techniques that we have so far. So if we wanted something to happen only if both conditions are true, we might use, let's say that we wanted a number between 1 and 100. We might use a structure like this, where we check to see if our number is at least 1, and then we check to see if our number is at most 100. And if both of those conditions are true, we do some output. Okay, so that's not too bad. It's definitely not too bad. Though that gets a little bit cumbersome when we have more than one condition. Alternatively, if we wanted to check to see if one or both conditions are true, what we might do is create a Boolean. This is using the Boolean flags technique that we talked about before. Check to see if our number is less than 0. If it is, we set our validity to false. Then check to see if our number is greater than 100. If it is, we set our validity to false. And then if our validity Boolean is false, we output invalid input. And there are a couple of different ways that we can roll with this. This is just one of many. Now, we can be faster about this by using the logical operators, the logical AND, which is this double ampersand, that's should be above the 7 key on your keyboard, and then the logical OR, which is a double vertical pipe. That's going to be right above the backslash key on your keyboard, which is usually right above the enter. We can use those operators to more finely control our if statements and to control the flow of our program. So the logical AND statement, this is sort of a very restrictive AND. It returns true if both of the arguments are true. The arguments are these Boolean statements on either side. Okay, so this number is greater than 0 and number is less than 100. We can maybe make that less than or equal to, but that's not too big of a deal right now. Okay, if that's the case, we output valid input, and that works. That works the way that it should. In this case, if this statement is true and if this statement is true, then the whole thing evaluates to true. Okay, so we check our first statement, we check our second statement, it just goes left from right. And then if both of those are the case, we do our output. We can think of AND as sort of a very restrictive AND. So for example, if someone were to say, hey, I would like a peanut butter and jelly sandwich, they'd be disappointed if you gave them a sandwich that only had peanut butter, or if you gave them a sandwich that only had jelly, or if you gave them peanut butter and jelly without the sandwich. The logical AND is sort of like that. It requires everything listed to be true in order for it to work, or rather it requires both of its arguments. Okay? A common error that we'll see with the logical AND is an impossible condition. So for example, this number is less than 0 and number is greater than 100. There exists no number in the history of numbers ever. There exists no numbers that are simultaneously less than 0 and greater than 100. It doesn't exist. This is a really common mistake, and it's a really easy mistake to make, and I just want you to see it right now so that way you know. Now let's say we have two conditions, and we're only really concerned with one of those conditions being true. So let's say that if the number is less than 0, or if the number is greater than 100, we discard it. Okay, so this is sort of the same. This is sort of the opposite, I guess, what we were doing before. Before we were checking to see if the number is between 0 and 100, and if it is, we keep it. This time we check to see if the number is less than 0 or greater than 100, and we discard it. So it's just sort of the opposite. In these cases, we can use the logical OR, which is this double pipe sign, just like so. So we check to see if the number is less than 0, or if it's greater than 100. So we check the first one, and if that's true, we don't worry about it. If it's false, we check the second one. And if both of those are the case, then we know that we've got good numbers. Or if both of those are false, we know we have good numbers. If either of them are true, this whole thing returns true. And we know that we have bad input. Now the vertical pipe symbol is, on occasion, difficult to find. So rather than you using a capital I or a lowercase l or a 1, you should be using the vertical bar, which is most often found on the same key as your backslash, which I've got circled here. Okay, so the logical OR operator is relatively permissive. So long as one of the operators are true, the whole thing comes back as true. Now in this course, what we generally use logical operators for, in this particular course, is to validate input or otherwise to validate numbers. We can do this two ways. If we want to use the logical AND, we check to see if our first condition is good and our second condition is good, we keep the number. Or if we're using the logical OR, we check to see if our first condition is bad or if our second condition is bad, and if either of those are the case, we reject the number. Okay, so that's we'll spend a lot more time with this as we go on through the course. With the logical AND truth table, and when we say a truth table, this is basically a here's our expression, this is the result, and these are things that ultimately you should probably have memorized, but it's intuitive enough that eventually you'll be able to figure out how to intuit your way through it, which is the way that it should be. Now the only way that we can get a true result from a logical AND statement is if both statements are true, right? If we have this true and true. If one of them is false, regardless of which one is false, the whole thing is false, and if both of them are false, the whole thing is false. That's how the logical AND works. It requires everything to be in order. The logical OR is a lot more permissive. The logical OR, if both of them are true, it comes back as true. If one of them is true, it comes back as true. And if neither of them are true, it comes back as false. Logical OR is a lot more permissive. So that's the one that we use whenever we don't care if all of the conditions are met, we just care that one of the conditions are met. That's the logical OR. When we chain together multiple Boolean expressions using the logical operators, when I say Boolean expression, what I mean is just something that eventually results in a Boolean. So any of the equality or inequality, or any of the equality or relational operators, for example. We evaluate the logical AND before we evaluate the logical OR. Both of them are evaluated left to right, and the parentheses rule still apply, but assuming that we're set with parentheses, we do the AND before the OR. Okay, so if we have something like this, where it's true and false, or false, and true and false, then the question that we might have is, oh no, where do we start? And the answer is we start by finding all of these logical ANDs. We have that one, and then this one, and then that one. This very last one is going to drop off here in just a second, so we're not going to worry about it. That is an error in the slide, sorry. So we're going to start with this true and false, or false and true. Okay, so we evaluate our logical ANDs first. So the true and false, we know that since only one of them is true, that's going to come down as false. Then this false and true, since we know that only one of those are true, that's going to also come down as false. And this true right here in the middle, we're not worrying about the logical ORs yet, and that's what this is attached to, so it just comes straight down. So now we have false, or true, or false. And again, we just go left to right, right? So we get false or true, which is going to come back as true. And then that false, which we haven't dealt with yet, is just going to come straight down. So now we have true or false, which true or false with the logical OR. That ultimately comes back as true, because only one of them needs to be true. And so this whole expression, this big honkin' complicated expression, ultimately comes back as true. Okay? And so we take this big honkin' expression, start with the logical ANDs, then work our way through the logical ORs, and ultimately we come back as true. Okay, so when you practice your logical operators, we can practice them just like we do arithmetic, right? Where you print out, where you create a Boolean that holds some result, and then you just make up some stuff, right? You can just make up really whatever conditions you want, solve it by hand, like we did on the previous slide, and then compare your work with Java. See if you get a good result. See if the result that you get by hand is the same as the one that you get by Java. And if it isn't, that's a sign that you should probably go back and check your handwork. Okay, and so I want to show you real fast what this looks like in programming. So I'm going to do a quick scan of everything. We've got this Vim logical operator set up. Okay, now this is a big file. So I've got the truth table for logical AND right here, the truth table for logical OR right there, a quick demo of the logical NOT, which we'll talk about here in just a second, and then a more complicated demonstration. We've got a result, and then we check to see how things work. Right? So this is where we roll with it. And this is the one that we're going to look at, right? This is the, incidentally, the expression that we just solved. And I want you to see that it ultimately comes back as true. Now, Java isn't going to show us the steps, but by comparing our end results and then working backwards, we can usually sometimes figure out where our errors are. Sometimes. Okay. So we're going to run this, baby. When we run it, so we're going to see the truth table, the logical AND, that true and true and this true, and that false and this false and that false. Those are generated by Java using the Boolean operations. You can examine the source code a little bit more closely to see exactly how that works. Same thing with the OR. These guys right here are generated by Java on the fly. We hard-coded this part. This part's generated on the fly. And with our more complicated demo, this true and false or false and true, that one ultimately works out to being true. And this is a thing that Java figures out on the fly. It doesn't get hard-coded. Okay? So, the last concept that I want you to be aware of, we're not going to spend very much time with this, is a concept, or the last concept with regard to logical operators that I want you to be aware of. We're not going to spend very much time with this right now, but when we get into methods here in about 4 weeks, we'll be able to go back and prove that this happens. This is a technique called Boolean short-circuiting, where if we chain together multiple Boolean expressions with the logical AND, our evaluation only goes as far as is necessary, and we call this short-circuit evaluation. So let's say we have something like this, right, where it's true and false and true and true. Now we can do the work by hand, right? So this true and true is going to become true, then true and false is going to become false, false and true is going to be false, and then false and true is going to be false. Now we can do that by hand, so this ultimately should work out to false, but the way this works inside of Java is we only get this far. As soon as we hit an expression that evaluates as false, we ignore everything after it. All right, this is short-circuit evaluation. And this is particularly useful when you know that one or more of your conditions might, under certain circumstances, crash your program. And very specifically, we're going to see this with array indices, and that's a thing that we're not going to talk about until about March. And what this lets us do is this lets us see do things where we have independent or dependent conditions, where our dependent conditions, if they become problematic, like first we check to see if it's problematic, then we check, then if it's not going to crash our program, we let things run normally. On the other hand, if it does crash our program, because we're using this Boolean short-circuiting technique, we don't have to worry about it. We don't have to worry about it even a tiny bit. Now the way to think about the Boolean short-circuiting technique is that this is sort of like we have a nested if statement for each one of these. Right? So we have a nested if this is true, then check if this one's true, then check if this one's true, then check if this one's true, and so on. And remember with the nested if statements, as soon as we hit that false, we skip everything after that. That's how our Boolean short-circuiting works. Okay? So when we, the last thing we have to talk about is the negation operator, which is this exclamation point. There's this negation operator. If we attach it to a statement that's ultimately false, that statement flips and becomes true. If we attach it to a statement that's ultimately true, it flips and becomes false. This one is particularly useful if you want a condition that's tricky to write. If you have a condition that's particularly tricky to write that you want, or where the inverse is tricky to write, we just want to discard it, right? So we can go back to before. We have if our number is less than 100 and our number is greater than 0, then we have valid input. And we can just stick an extra set of parentheses in here, just like so, and put the negation operator right in front of it. If our number is less than 100 and greater than 0, then we flip it. We know that we have invalid input. Okay, so when we come back, the thing that we're going to talk about is the character data class. And I'll see you in just a second.